All right, so before you continue this rest of this video, you should really just pause and see if you can't complete this unit circle and chart completely. I'm going to fill in the angle measurements for you so you know all the angles that we're trying to do. We're going to just go up. The next one after 90, the next special angle would be 30 degrees more, so it's going to be 120. And then you're going to add another 15, you get 135, and then you get 150, and you get 180. That's all the second quadrant. Then the third quadrant is going to go 210, 225, 240, and then 270. And then the last quadrant, we got 300, 315, and 330. And then we go back to 360, which is this one right here. Starts over. So I want you to fill that all out. You need the practice anyway. So just pause, take whatever time you need, fill that out, and then come back when you're ready to continue. Okay, hopefully you did all that. And I just want to point out that there is now a PDF of this on my Google Classroom. It should be linked on the Edpuzzle somewhere, and I want you to take a look at that and make sure that you fill it out correctly. So you can use this to refer back to from now on, but still want to be able to generate this unit circle on your own. So we're going to refer back to this completed chart, and you're going to use that to answer some of these questions. Let's go for it. All right, it says use the table. We want exact values. Let's take a look here. Cosine of 150. Well, if you go over to the table, you should have, if you look down the cosine column, you should, and I'm sorry, the cosine 150 and find the cosine column, you should be able to find out what the cosine of 150 is. But I like to just look at the unit circle. And if you look at the unit circle at where 150 is, the coordinates that you get on that unit circle, you're going to get something like this. 150 degrees. Over here in the coordinates, you're going to have negative square root 3 over 2, comma, positive 1/2. Remember, cosine, comma, sine. The cosine is your x, sine is your y. So there's my answer right there in exact terms. It's negative square root 3 over 2. Beautiful. All right, now they want cosecant of 2 pi thirds. Remember, important though, cosecant is the reciprocal of sine. So this is the same thing as saying 1 over sine of 2 pi thirds. Well, what is sine of 2 pi thirds? Again, look at the unit circle at 2 pi thirds. 2 pi thirds is the same thing as like 120 degrees. Hopefully you see it there. And the sine value, or the y value of the coordinate is positive square root 3 over 2. Again, I am just going to the unit circle either in radians or in degrees and finding the appropriate coordinate. So here, even though they asked for cosecant, I know that's just a reciprocal of sine, and so I'm just going to do 1 over that. Oh, but I made a little mistake here. Remember, it's the reciprocal of sine 2 pi thirds. So what I have right here, this is what sine of 2 pi thirds equals. But if I want the reciprocal of that, then the real answer here would be 2 over square root 3, which when we rationalize is multiply. I'm just going to go ahead and do it because I don't remember. You end up with 2 square root 3 over 3. Boom. Okay, so that's the real answer. Ignore that. I mean, don't completely ignore it because we have to use that to get the answer. Then we just flip it. That's how we get the answer we want. All right, tan of 270. Now, this is kind of written real funky. Typically, you're going to see parentheses here so that we know, hey, we're taking the tangent of negative 270 degrees. But what I like to do is first figure out, well, where's my positive angle? Well, negative 270 is the same thing as tangent of 90 degrees. And remember, tangent is just sine of 90 over cosine of 90. And these are one of your four corners where the sine of 90 is 1 and the cosine of 90 is 0. Well, we cannot have 1 divided by 0, can we? And so we get an undefined here, right? That's undefined because we can't divide by 0. All right, lastly, we get this sine of 405. Sine of 405, that's not even on our unit circle. Well, here's what you need to think about. 405 is the same thing. I want you to think of it like this for now. It's 360 plus 45. So I want you to imagine you went around a full 360 degrees. There's 360. And then you added another 45 to it. That's going to be the same thing as having a theta of 45 degrees. it's a like coterminal angle. It just keeps going. It just repeats it forever and ever and ever and ever. So we could keep adding 360 to 45. And we could keep getting another angle that's exactly the same. So that means this angle is equivalent to the sine of 45. So that's all I'm going to do. I'm just going to evaluate the sine of 45. And if I look at my unit circle, the y-coordinate right there at 45 degrees is rad 2 over 2. So this answer is square root 2 over 2. Boom. All right, now what about approximate values? Approximate values means we're going to use the calculator. But I want to point out something to you. Notice that this is degrees, this is degrees, this is degrees, but this one is not. That means this one, when you use your calculator, you're going to need to be in radian mode. Radian mode. It's pretty simple. You just hit mode, and then you'll see like some options there. If you a few lines down, one says radian, one says degree. For these ones, you want to make sure degree is highlighted. For this one, you want to make sure radian is highlighted. So let's make sure your calculator is in degree mode, and we'll do these ones in degrees first. So first one's pretty straightforward. You're literally just going to type that in directly. So cosine 150, and when you type that in, you should end up with negative 0.866. We're going to round to 3 decimals unless they tell us otherwise, okay? Negative 0.866. All right. Next one, secant of 210. Oh no, but we don't have a secant button on our calculator. What are we supposed to do? Well, that's no big deal. Secant is just 1 over cosine. So this is the same thing as saying cosine of 210 on the bottom of 1. So 1 divided by cosine 210. And that's exactly what we're going to put in our calculator. 1 divided by cosine 210 degrees. Boom. We get negative 1.15. And then we'll round that last one to 5. And we have it. I'm going to skip the radian one for now. We'll come back to it. Let's do the other degree one. This is cosecant. Cosecant is the reciprocal of sine. So this is the exact same thing as saying 1 over sine of 170 degrees. And again, that's exactly how I'm going to put it in my calculator. And I end up with 5.75. The last one would round to a 9. Boom, boom, boom. All right, let's talk about this cotangent one. Before I plug this in my calculator, I do need to make sure my calculator is in radian mode. So go back to that mode setting and click radian, hit enter, and then you can just hit second quick, go back to the main page. Let's talk about what cotangent means. Cotangent is simply the reciprocal of tangent. So it means tangent 5 pi 6, but all underneath 1. And that's exactly what I'm going to plug into my calculator right there. 1 divided by tangent 5. Use the pi button, okay? Use the pi button, don't use 3.14. Divided by 6. I plug all that in, and I end up with negative 1.732. Boom. So that's how you can use your calculator to solve that work. Might take a little bit of work. Sometimes you gotta like think about how to write it as sine, cosine, or tangent, because that's all your calculator really has. But it's no big deal. If you know your identities, you'll be fine. Okay, this one wants us to use a table to solve for this. I, again, would just use the unit circle. So what I'm going to do here is I'm going to look and see when does the cosine equal 1/2. And remember, just a little reminder that this is really just saying when is the x 1/2. Well, just to give you a quick little rundown, I'm just going to sketch it real quick so I can talk about it. On the unit circle, I get a 1/2 for the cosine right here, and that's at 60 degrees. And if you go straight down, you got to think, since this is an x value, right here, your coordinate should look like this. Okay, since cosine is really an x value, I got to think, when is this x value the same? Well, it's the same if I go straight down. And so down here, you get the same cosine value, the same x value at 300 degrees. And so you'd have 1/2 negative square root 3 over 2. And so the answers here are when theta equals 60 and 300 degrees. So I actually don't really like to use the table for this. I mean, you're more than welcome to, but I like to use the unit circle and just think of the fact that, hey, these are both x values, so I'm just looking for the 2 parts that have the same x. If it was sine, I would look for the 2 times when I have the same y. So that's all you're really doing here. For this one, again, the table would be really nice for this one. So if you want to look at the table and see if you could find this, you can. But I'm going to look at the unit circle, and I'm going to try to identify this. So I know that tangent is always sine of my angle over cosine of my angle. And in order to end up with a square root 3 on top, I'm going to need I'm going to need something that has a square root 3 on top here. And the only ones in my unit circle that have square root 3s are always square root 3 over 2. So in order for me to get a sign where I have a square root 3 over 2, and for it to be negative, I'm going to have a positive on the bottom, and I'm going to need that 2's to cancel out. So I'm going to have a 1/2 on the bottom. Or I could have a positive square root 3 over 2 over a negative 1/2. Okay, so I'm looking for these two scenarios. I'm either looking for when my cosine theta is negative 1/2 and my sine theta is positive square root 3 over 2, or when the sine is negative 3 over 2. I'll highlight this one red, or this one. Okay, well, there's two scenarios on the unit circle where this happens. We get a negative square root 3 over 2 and a positive 1/2. That happens when our theta is 300 degrees. And then we get this second one, the one that I highlighted in blue. That happens when our theta is exactly 120 degrees. And those are the only two times we get that scenario. And I just thought about that because the reason why I was able to do that, I'm familiar enough with the unit circle to know how would I end up with a square root 3 on top. It'd have to be something like this. You'd have to have a square root 3 over 2 divided by 1/2. And so these are the scenarios where that would take place. And so that's how I could whittle it down. Now, once again, if you have that table that we filled out, you could just look and see, hey, when do you get a tangent a tangent theta equaling negative square root 3, and then that chart will help you answer that as well. But like I said, I like to just use the unit circle, so it's totally up to you. Okay, let's take a look at these. Now we're going to use inverse trig using the calculator. This is when you hit second and then that appropriate trig button. Just to give you a little brief rundown, the inverse trig functions, so like sine -1 of sine theta just equals theta. Like these are the inverses of each other. They inverse each other, you just get that thing back. Okay, or the inverse cosine of cosine theta just equals theta. Or the inverse tangent of theta just equals theta. So all that to say, we're going to use these inverse things to solve. What would that look like? Well, you don't actually have to do this part, but I want you to mentally think that you're doing this. You're going to take the inverse cosine of both sides. These will cancel each other out, and then you're going to have theta equals this, the inverse cosine of 0.2079. Well, that's no big deal. Let's just plug that into our calculator. And we end up with theta equals 1.361. And I would say like we're going to round this to a 4. So theta is 1.3614. My calculator is in radian modes right now. Oops, so let's do it again. Sorry, that's in radians. That's why that seems a little bit weird. So I'm going to change my calculator mode to degrees. And then I should just be able to re-enter it, and I'll get it in degrees. And now we get something that makes a little bit more sense, 78.001 degrees. So about 78 degrees. All right. Okay, what about something like this with cosecant theta? Okay, remember, though, that cosecant is just 1 over sine. So this is really, oh, let's change color. So this is like saying 1 over sine theta equals negative 1.2062. And I know this seems a little bit weird, but what we're going to do is we're going to think of this as like being over 1 because I need to get this all by itself. And so what I'm going to do is an old proportion trick is if this is a fraction and this is a fraction, well, I'm allowed to just literally flip both sides. I can think of it like this. Sine of theta over 1 equals 1 over negative 1.2062. And now I have sine of theta all by itself. I don't really care about this 1 down here. And so now I'm going to do the arc sine to both sides. And so, again, this is usually not a step that you necessarily have to write out every time, but you end up with theta equals the arc sine of 1 over negative 1.2062. And now you're ready to plug in your calculator because you have it in terms your calculator can understand. So let's go second sine 1 divided by 1.2062. When I plug all that in my calculator, I end up with 56.001 degrees. Boom. If you wanted radians, you could do it in radian mode, but again, they told us this was in degree mode, so I'm sticking with degrees. All right, now I'm at cotangent. Okay, there's no cotangent button. Again, though, that's okay because it's just a reciprocal. So I could go ahead and say, well, the tangent then of theta would have to be the reciprocal of this. It's just 1 over 1.42. And therefore, theta would have to be the arc tangent, or the inverse tangent of 1 over 1.42. And I'm going to go right to my calculator with that. When I plug that in, I end up with 35.154 degrees. Boom. Okay, so even though you're using the calculator here, you still have to have some basic trig knowledge. You got to know how to rewrite these in terms of sine, cosine, or tangent, because those are the only things, those are the only buttons your calculator has. So there we go. All right, let's go on to the next page. All right, on these ones, I want you to try these, okay? Go ahead and spend a few minutes trying each of these problems, just like what I did on the previous page. But I will tell you, there might be something fishy here with number 6, okay? So try all these, work them all out, and then unpause the video when you're ready to check your work. Okay, so some of these were easy. This is simple, plug it right in your calculator. Not so simple, you got to think of it in terms of sine, which means you need to do 1 over sine 128, then you can plug it in your calculator. Same thing here, you got to think of this as 1 over tangent of negative 28, then plug it in your calculator. All right, on this one, pretty straightforward. We just do the inverse cosine of both sides and we get our angle measure. Here, though, I need to think of it in terms of sine, which means I have a reciprocal. So I'm going to take the reciprocal of both sides so that I can get sine all by itself. Then I can do the arc sine of both sides, and I can plug this. Into my calculator and get 44.371. So here's the thing I notice students do all the time. They think, oh, I can just use my calculator. Yes and no. You can only use your calculator when you're ready to use your calculator. This is not calculator work. This is the only thing that you're plugging in your calculator. All right, on this one, when you plug this in, your calculator should have been like, what are you doing? This doesn't work. Well, here's why. Let's go back in time to IM2 or geometry, and let's think about what is sine. Sine, as we originally learned it, is the opposite over the hypotenuse. So if I was to draw a triangle here, and this is my theta, this would be my opposite, and this would be my hypotenuse. And the hypotenuse is always the biggest side, right? Are we satisfied with saying the hypotenuse is bigger than the opposite? Which means if this is always bigger than this number, then it is safe to say that this has to be less than 1. Think about it. This number cannot be bigger than this. If it was, we wouldn't really have a triangle anymore. So what happens in order to get 1.2? The number on top would have to be bigger than the hypotenuse, right? And so we could say something like, to get sine of theta equaling 1.2, the opposite would have to be bigger than the hypotenuse. But that is impossible. And so that's why this simply does not exist. So sine, as we know it, can oscillate as high as 1 and get down to as low as -1. But it cannot be anything outside of that. So, and it could be equal. So you could say that this is like the range for sine. It could go up to 1 and down to -1, but it can't not go outside of that. Same thing is true for cosine, actually. Not true for tangent, cotangent, all that, but it is true for sine and cosine. So just keep that in mind, right? Like you can't get a cosine value that's bigger than 1. Okay, that's it for this video. Don't forget to ask me a question. I'll see you guys on the next one.